So I'm finally getting around to heat treating the small knife I made in my last video. I'm not going to talk about the austenites, the martensites, the cementites, the ferrites and all that stuff. I just want to show beginners the basics, so I'll simply refer to the different solutions and compounds of iron and carbon as the grain, and possibly make a more advanced heat treating video later on. Also simplify things quite a lot. So to harden a tool steel you need to heat it up and cool it down fast. This is called quenching. The faster you cool the steel, the harder and more brittle it will be, so you don't want to cool it down too fast. I'll be quenching the knife in vegetable oil, which will cool the blade slower than water, thus making it less brittle. However, it will cool the steel a little too slow, so I'll preheat the oil to about 70 degrees centigrade in order to increase its viscosity. I'll do this by dropping a hot metal bar in the oil. In order to keep an eye on the temperatures, I use an infrared thermometer. After quenching, the steel will be hard and brittle, so it will need to be tempered. There are several ways to do this, but for a short blade I do it with a controllable induction heater and a pan of oil, heated to between 220 and 230 centigrade. This corresponds with a straw to dark straw temper colour, but because temper colours are a form of iron oxide, they won't show in the oil bath, which is an oxygen-free environment. Because I'm heating a pan of oil, I keep an old apron nearby in case it bursts into flames. The oil, not the apron. To show the grain phases of the steel according to their heat treatment, I made some test pieces as well. The first sample was brought to a bright yellow heat and quenched in cold water. I then nicked it with the grinder and hit it with a hammer. As you can see, the top part just flew off with no effort whatsoever. The grain is very enlarged, which is synonymous with brittleness. The second sample was brought to what is known as the critical temperature, or the Curie point. An indication of this is when the metal becomes non-magnetic, because the grain is in a transitional phase. The sample is laid to one side to cool at its own rate. This allows the grain to align itself and to form even crystals. This is known as normalizing. Performing the nick test, you can see that it takes 2 hammer blows to break the top off, and the sample bent before breaking. Looking at the grain, you can see that it's smaller and more refined than the previous sample, which is what made the sample slightly tougher. The third sample is brought up to critical and hot quenched. I wait for the exact temperature to be correct before putting it in the oil. Notice how I move it up and down in order to prevent a shield of bubbles forming around the sample, which would slow its cooling rate. When it's quenched, I temper it for 2 hours at 220 C and let it air cool. I then perform the nick test. As you can see, it takes a lot more effort to snap the top off, and when it does eventually break, it's because I accidentally performed the nick test on a leftover rivet hole in the steel. Looking at the 3 samples side by side, you can see that the tempered steel is slightly coarser than the normalised sample, and a slightly different colour, while the grain boundaries are more clearly defined. The sample bounced at first rather than bending or snapping. With all this in mind, we'll move on to the knife. Note that I left the edge about 1 mil thick. This is to prevent the edge from distorting, overheating or losing its heat before the quench. The blade is laid on top of the fire with the fire running slow. I want to heat it slowly and evenly, and it needs to soak at temperature for a few minutes in order to allow the grain to start transforming throughout the whole blade. If you don't give it time to soak, then it will run the risk of central parts of the blade not transforming. When it's at critical, I put it to one side to cool down to room temperature, like with the sample. This is called normalizing and reduces the stresses in the blade, which will both help create an even grain as well as preventing the knife from deforming during the quench. I'll repeat this process a couple of times. After the second normalizing cycle, I heat the blade again, making sure to have an even heat. I test the blade for magnetism and then quench it in the warm oil. Again, I make sure to move the blade up and down in order to prevent the bubble shield. The blade is then placed in the tempering bath at 220 centigrade for 2 hours. I repeat this process twice in order to make sure that all the grain is allowed to shrink. After both tempers, the blade is allowed to air cool. After the tempering process, I finish putting an edge on the blade. It's important to keep the blade pointing downwards because if it catches on the belt, you'll be digging it out of your foot. Whilst grinding, make sure to keep cooling the blade in a tin of water as you don't want to damage the temper on it by overheating it. The final sharpen is given with some whetstones. I only ever give a utilitarian edge to the knives I make as I like to keep them general purpose. After sharpening, I heat up a solid bar and lay the knife on it at the transition between the blade and the handle. Though you can't see the colours, it doesn't really matter as I'm deliberately softening the blade at its weakest point to prevent it from running the risk of snapping. On a functional knife like this, I leave the oil finish on as it keeps the blade waterproof and prevents it from rusting. Thanks for watching this video. Any questions you have, feel free to ask in the comments. Please subscribe to keep up with new videos.